So this is review of topic 2. Topic 2 is breaking it down. If you cannot do this today, then topic 3 is going to be very difficult for you. Okay, so if you don't understand this, I need you to ask questions before we take our notes today. The first one says 2 square roots of 54. What can 54 break down into? 6 and 9. 6 can break down into, and then I circle them because I cannot break them down. 9 breaks down into, and again circle. So when I rewrite this, I have 2 square roots, 2 times 3 times 3 times 3. What am I looking for? Groups of, how do you know? There's no index. My index goes right here and it's invisible. So what does that mean? It's groups of 2. What do I have 2 of the same? 3. So I take that out. What do I do to numbers outside? Multiply. So I have 6. And what do I do to numbers inside? Multiply. And it just happens to be 6 square roots of 6. Questions on number 1? What's different about number 2? It has a negative and the index is a 3. Okay. So first of all, let's talk about this negative. Does this negative turn into an I, or does that negative come outside? Why does it come outside, Jerry? Uh-oh. Why does it come outside? What is odd? So since my index right here is odd, that means my negative just comes outside. If it was even, then what would happen to my negative? It turns into an I. Okay? So this negative is just going to come straight outside. Okay? All right, now what can I do to 64? 8 and 8. What does 8 break down into? 4 and 2. And what does 4 break down into? 2 and 2. Very good. And same thing over here. 2 and 4. 2 and 2. Those are a bunch of different looking 2s, huh? All right, so when I write this right now, I have the cube root. -1 is outside, and then what's going to be inside? 6, 2. What am I looking for? Groups of how many?
3.
Of 3. My index tells me I need 3 of them. So here is a group of 3, and here is a group of 3. What do I do to numbers on the outside? Listen, because here's where you're messing up. I multiply 2 times 2, which is times 1 is, do I multiply by that little bitty 3? No, that's just an index. So what number is outside? Is there anything left inside? So do I have a radical in my answer? No.
But you don't have to put the little 3 either.
That goes with your radical. Is there a radical in my answer? So can I have an index in my answer? No. Okay. All right. Questions on this? Okay. Make sure that you are writing that index teeny tiny, or you're going to be confused the next few days. Okay. All right. Let's take our notes, and then okay, let's take our notes and then we will get some practice in today. So today we are on Unit 9. Unit 9, Topic 3. And it's going to be called Operations of Radicals. Operations means add, subtract, multiply, and divide. Today, we are only adding and subtracting, okay? So you will have a quiz over the 3 topics of Unit 9, and it will be on Thursday, March 10th. If I were you, at the top of your paper, I would write add and subtract big, because that's what this page is going to be on. And then on Monday is when we will multiply. Okay, so I'm going to add and subtract today. That's it. Now, there are 3 very important rules you have to follow to add and subtract. And if you have messy work everywhere, it's going to be hard to follow it. So you've got to have your work nice and neat, and then you can have scratch messy work on the side. Okay, so the first 3 rules we have to know. Number 1, your index must match. So the index must match. I can't add a square root and a cube root together. Those have different index, okay? So my index must match. The second thing we have to make sure is that we only add or subtract outside numbers. We only add or subtract outside numbers. Okay, and here's going to be the trickiest one to kind of remember. 2 things together. Inside numbers match, and stay the same. And I'll show you what I mean by that when we do our problems. So the inside numbers must match, and they have to stay the same. They will not change in my answer, okay? Which is kind of confusing when we get to the problem. All right, so we're going to do 4 problems. So example number 1 is the easiest type of problem I can have. It's going to say 3 square roots of 2 plus 5 square roots of 2. So you got to check for 2 things. The first thing I have to check for is, does my index match? So do these problems have the same index? Yes. What is it? It's a 2. Okay. Next thing I need to check, do the inside numbers match? So do these have the same numbers inside? Yes. Then this is as easy as a problem can get. Index match, inside matches. Now, to actually do the adding, I only add or subtract outside numbers. So I'm only adding the 3 plus the 5. So 3 plus 5 is 8. And then what does it say about the inside number? Stays the same. So it's going to say 8 square roots of 2. That will be my answer. Okay. So it's kind of, you don't have to write this down, but it's kind of as if I were to say 3x plus 5x. Why can I add those together? Because they both have exactly 1x, and we only add the number in front, right? Okay, that is exactly what this is. So this would be similar to my x. It's like your unit, and then I add or subtract the numbers in front. Okay. All right, so example number 2. What if it says 3 square roots of 8 plus 4 square roots of 8? So the first thing I have to check for is, does my index match? Yes. Do my insides match? Yes. So I'm okay to then do what the outside says. And the outside says 3 plus 4. What is 3 plus 4? 7. And what's going to stay behind it? Square root of 8. This is wrong. Why is this wrong? Because I can do something to that square root of 8. What can I do to square root of 8? I can go simplify it. So I'm going to go to the side of my paper where my messy work's going to be. And I'm going to write 7 square roots of 8. And we're going to simplify. So what can 8 simplify down into? 2 and 4. And then 4 simplifies to 2 and 2. So I have 7 square root of 2 times 2 times 2. What am I looking for? Groups of 2. Groups of 2. My index is 2. What happens to the 2 and 7 because they're outside? So I have 14 square root of 2. So what can I write instead of 7 square roots of 8? What does this really equal? 14 square roots of 2. Because we had to simplify. Okay. Questions so far? Okay, so we're going to go make it just a little bit harder now. Okay. So I'm going to have -9 square roots of 12 minus 2 square roots of 3 plus 4 square roots of 16. Okay. Now, here's what I would do. First of all, let's check our index. Are all our index the same? Okay, we're good to go. Are the insides the same? No, but what do we see we can do to this 12? Break it down. What can we do to this 16? Okay, listen, you have 2 choices to keep this organized. Number 1, you take these to the side and you work them out. Number 2, you can make this basically 3 separate problems. So I'm going to put lines down the center like this, and it might help organize. Do you see how that symbol still stays with the number it's attached to? Okay, so now let's go break down 12. So everybody on their paper, break down 12 and get me a new radical. Okay, and you can look up to check your answers. So everybody's breaking down. Don't just copy. If you need help, ask. I can help you break it down. All right. We broke down 12 and we got a 2 outside and a 3 inside. So where did I get -18 from? I multiplied that 2 that came outside to get me -18 square roots of 3. Why did I write -2 square roots of 3 down here? I can't do anything to it. And then what is the square root of 16? It's just 4. So what's 4 times 4? 16. Do you see how I have them all nice and neat now? Okay. Which ones can I actually add or subtract together? The first 2. These 2 can add or subtract together. Why can this one not add or subtract? It doesn't even have a square root anywhere in it. So if I combine these together, what is -18 and -2? What's that going to give me? -20 with a square root of 3. And then this plus 16 is just going to hang out behind it. And together, That is my answer. Okay. We're going to go try one more. So my last example is going to say 3 or cube root of 54 plus cube root of 16 minus square root of 24.
That's a plus sign.
Yes, plus, sorry, my pen, my pen is, there we go. Okay. So again, I'm gonna draw my lines so that I have separate, nice, neat work, or go to the side and do it. Okay. So break these down. I'll give you a minute. I'll put my work up here so that you can see it and then look up and check. What's different about that 24 when you get there? Who can tell me what's different about the 24? The index is different, so you got to be careful when you break it down, okay? Everybody should be breaking down. So look up just to check if you got the same things I did when you broke it down, right? We need another 30 seconds to finish breaking down. Okay, you should be breaking down all three, 54, 16, and 24 can all be broken down. I just know that it's a 2. Well, I wrote it in there because what am I looking for? Groups of what? 2. I just wrote it in there to remind myself that I'm looking for groups of 2 because there was no index, right? Okay. All right. Now I have, why is it negative? Because it says right there, negative 24, negative square root. That negative's outside, so it's got to stay outside. Just like my plus sign here, positive, I got to stay. So that way when I actually add or subtract, I know what I'm doing. Okay. Which ones of these can I actually combine together? The first 2, why? They have the same index and they have what else the same? The inside number. So when I add these 2 together, I'm adding 3 plus 2. What will that give me? 5 cube root of 2. And then the one that can't add together just goes at the end. And there would be my answer. Why can I not subtract 5 and 2? They have a different index, first of all. Why else can I not subtract them? The inside numbers are not the same. Very good. Questions? Okay, you have a packet at your table. There is a paper that looks like this, has 12 problems. This is your goal today, to get these 12 problems completed because tomorrow we got word problems. Are you writing on my packet?
No.
Don't you dare.